So today we'll be looking at router on a stick and layer 3 virtual interfaces on Cisco switches. So we're going to start out here. We have router 1, router 2, connected in between switch 1 and switch 2. So over here on router 1, we're going to set up a few interfaces. So if we do show IP interface brief, you'll remember that on Viral, the gig 00 is kind of an administrative interface. So we'll be working with gigabit 0/1, as you can see from the Viral interface designation. So we come over here, we go into interface gig 0/1. It is administratively down by default, so we will do a no shut command. Once we do a no shut, that will turn it back on. So if we do show IP interface brief, you'll notice now that it is up. It is now considered, of course, a physical interface. We can configure it as such, or we can work with sub-interfaces. When we talk about sub-interfaces and router on a stick, this is where we terminate VLANs in our infrastructure. Now if I come over here to switch 1 and do a show VLAN, and switch 2 and do a show VLAN, you'll notice that I have VLANs 1, 2, 3, 4, and 5. I have also, when you do the show interface trunk command, sorry, let me spell that right. Show interface trunk and show interface trunk. This will show you that the VLANs 1 through 4094 are allowed on gig 1 and 2. As you see here, gig 1 and 2 are trunk ports between each other and between the routers. This allows us to do our VLAN on a stick and have our systems communicating. You also see here that VLAN 1 is not being allowed on gig 0/1 over here on switch 2 for some reason. Anyway, we'll figure that one out later. So, over here on router 1, we're going to be creating a gig 0/1.2. I gotta remember, this is a sub interface. It doesn't really tie into anything except to basically give you representation of a physical interface. Now, when we specify the encapsulation, we can specify .1q, which is pretty much the de facto, and ISL, which has basically been deprecated, but it's still available for us to look at in this instance. So we'll do encapsulation .1q and then the VLAN ID of 2. With the .q VLAN ID of 2, we'll give an IP address of 10.0.2.1, as this is router 1, and we'll put it on a /24 network. Now we'll do the exact same thing over here on router 2. Interface gig 0/1. Now you got to remember, it has to do no shutdown. Interface gig 0/1.2. Encapsulation .1q VLAN 2. IP address 10.0.2.2 with a /24 mask. Now once this is done, we can end out of the configuration and do a write, and then we can do a show IP interface brief to see that the sub-interface has been configured and there's an IP address applied. Now once you have these IPs applied and make sure that your VLAN 2 is allowed across the network, we can try do a ping. And as you can see, after our ARP took place, we were able to ping the endpoint. As you can see here, 10.0.2.2 has a hardware MAC address. If we come down here and do a show interface gig 0/1.2, you'll notice that the FA163E7F F551 is on the virtual interface for gig 0/1.2. and is also seen in the show MAC address table down here on the switch. So you can see there's a lot of these FA16s on here, but the F551 is down here off of gig 0/2. This is what allows us to do our routing on a stick. So if we do a show IP route, you'll notice that we have our connected routes. All the connected routes on here can be routed to by default. So let's come back in here and do another config. Interface gig 0/1.3. We'll do an IP address 10. Let's see what it was. 10.0.3.1 with a /24. I got to remember, IP routing on LAN interfaces is only allowed when you configure a trunk or encapsulation. So let's try this again. Encapsulation .1q VLAN 3, and then reapply the IP address. Now we'll do the same exact thing to .4. We'll put this in encapsulation VLAN 4. We'll give this an IP address of 10.0.4.1. Next we'll do a subinterface of .5, encapsulation .1q of 5, and an IP address on 10.0.5.1. Now once this is all done, we can save our config, show IP interface brief to make sure they all took, show IP route to show that they're all as connected and local originated routes, and they're all here. So now we'll do the exact same thing to router 2, but we'll also look at our configuration here, which one of the nice things, I'll show you a notepad here. So interface, let's just copy all of this out, paste it, Control H, we'll replace let's see, sorry, 2.1 with 2.2, 3.1 with 3.2, 4.1 with 4.2, and of course 5.1.5.2. Nice little quick way of allowing us to put all these interfaces on the secondary router. So once we get into our configuration mode and paste out all the commands, do an end and a write. So let's see if this will work. 10.2. Let's see, 3.2. And of course it shows it doesn't work. So let's try 0.3.2. Of course, if it's not in the show IP route, it's not going to work. So 4.2. Got to remember, the first missed ping is the ARP request, because you cannot ping an endpoint without a MAC address. And there you go. 10.0.2, 3, 4, and 5 are all working. We didn't do a VLAN 1, so there's no real point in testing that. So you're going to see here once again that router on a stick allows us to do our VLAN encapsulations on the routers. Now keep in mind, once again, if you don't have the VLANs on your switches, this will not work. So now we have our router on a stick. Another thing we can do, if we don't want to have router on a stick, we can actually create VLAN interfaces on a layer 3 switch. So in this case, switch 1, we'll do a VLAN 2. This will have an IP address of 10.0.2.3/24. We'll do the same thing for VLAN 3. So that'll be 3.3, VLAN 4, that will be 4.3, and lastly VLAN 5. We'll save that configuration, do a show IP route command, which of course you're going to see that gateway of last resort is not set. So let's do a show run and include for routing. If you don't find routing, you have to enable routing by default on a Cisco switch. So if you type IP routing in configuration mode, this should turn on the routing process. So when we do a show IP route, it'll eventually come up and give us the routes. Yeah, okay, well that sucks. Apparently we don't have layer 3 on this switch. After all, it is an iOS layer 2 switch, so that's probably why it doesn't work. Alright, well anyway, we understood what the router on a stick and how that works. You put sub-interfaces on a single physical interface, which provides us the encapsulation for the VLANs and the router on a stick scenario. Albeit I can't show you the IP routing right now, we can do a show run and you'll see all of the IP addresses listed on the VLANs. Oh hey, what do you know? Maybe that's why. Config T, interface VLAN 2, no shut, do show IP route. Okay, well, 3, no shut, 4, no shut, 5, no shut, and show VLANs. Okay. Show IP interface brief. Show IP route. There you go. For some reason, in the virtual iOS and viral, the VLAN interfaces, or SVIs, switch virtual interfaces, are shut down by default. But you're going to see here now that we have the ability to ping 10.2.2.1 Okay, that's kind of odd. Let's do a show ARP here. Getting hardware addresses, it's showing us which VLANs they're on. So let's try the interface trunk again. Encapsulation is .1Q, status is trunking, native VLAN is 1. All VLANs in spanning tree are forwarding and not automatically pruned, or manually pruned for that matter. 10.0.2.2. Oh, and there it works. Did I do the wrong IP again? Yes, I did. I did a 10.2. Oops. Okay, 10.0.2.2, 10.0.2.1, 3.1, 4.1, and 5.1. So technically, the router on a stick and the switched virtual interfaces are pretty much the same thing. You're just applying IP addresses to VLAN tagged interfaces. As you can see here, VLAN subinterface with an encapsulation of a VLAN. So once again, we'll do a show run interface gig 0/1.2, and of course it's in VLAN 2. So that's pretty much it, the difference between switched virtual interfaces and subinterfaces. They basically work the same way. They're based on VLAN. And don't forget, if you're using Viral, you need to make sure you do a no shutdown on your VLAN interfaces, otherwise you'll be like me. And not to mention, make sure you put the right subnets in. IP addressing is always kind of a pain, and if you don't get that right, you're going to have a big headache. So hopefully this has been good. You can understand the difference between a layer 3 switch and a router. Yep, and there we go. Thank you very much.